Yellowstone National Park, home of the Yellowstone Supervolcano, also has a dark secret. It periodically coughs up massive amounts of sulfur dioxide gas, and this is bad news for all life nearby, including us. But the real kicker is why this happens. A minor eruption at Yellowstone may actually be the worst-case scenario. So what exactly are we worried about? In August of 2022, scientists at Yellowstone noticed something odd. For over a year, the park's most active geyser had gone quiet. Steamboat Geyser typically erupts every few days, but in the summer of 2021, its activity ceased completely. But after more than a year without an eruption, the geyser blew its top on August 21, 2022, spewing boiling water over 300 feet into the air. But even as onlookers marveled at the massive plume of hot water vapor and dust shooting kilometers into the sky, some scientists were deeply concerned. It's not uncommon for Yellowstone's most active geyser to take a break, but no one had ever seen such a prolonged pause before. Plus, there was another weird thing going on. The ground around the geyser was swelling upwards by the minute. Satellite imagery clearly showed that something big was happening beneath the surface. When Steamboat finally blew its top again, it became clear what was going on. A magma chamber below the surface had swollen with rising molten rock. As it pushed upwards, the surrounding ground buckled and heaved until the pressure became too great, and the magma forced its way to the surface through Steamboat Geyser. This is common behavior for Yellowstone, which sits atop a massive supervolcano that sprawls across 3 states. More specifically, Yellowstone sits atop a gigantic magma reservoir created when a plume of hot rock known as a magma batholith cooled beneath the surface tens of millions of years ago. But because it's so massive, the cooling process didn't happen evenly. Instead, the enormous size of the magma chamber led to uneven cooling. This means that some areas of the magma chamber are hotter than others. Hotter equals less dense, meaning the hottest sections don't stay put. They bubble up toward the surface while cooler, denser sections sink down toward the core of the Earth. These rising bubbles of hot rock are called magma diapirs. They can travel upward for hundreds of thousands of years, pushing their way toward the Earth's crust. When they reach the surface, they create features like geysers and hot springs. And this is where things get interesting. See, when these magma diapirs come closer and closer to the surface, they start to pick up speed. That's because the closer they get to the surface, the less dense the surrounding rock is, meaning the diapir experiences less resistance as it travels upwards. At some point, the rising magma diapir reaches the boundary between the less dense upper crust and the much denser lower crust. At this point, the rising diapir literally hits a wall and can no longer travel upwards. It's here where things get really dangerous. When a magma diapir reaches the boundary between the upper and lower crust, it can't move forward anymore. It will instead spread out sideways, creating immense pressure in all directions. If it manages to breach the surface, this sudden outward expansion can cause explosive volcanic eruptions. This is why Yellowstone is considered a supervolcano. It has the potential to produce truly massive eruptions that cover vast swaths of North America in ash. But there's another serious problem brewing beneath Yellowstone. While it's mostly famous for its incredible Old Faithful geyser, Yellowstone is actually home to hundreds of geysers, and they're in serious danger. See, when a magma diapir approaches a geyser, the rising heat causes the water table below the surface to boil. Once the water boils, pressure builds up until it's great enough to blast water vapor and hot water high into the air. That's how a geyser works. But if a magma diapir continues to heat the water table, the water will boil off completely. Without water, a geyser can't form, and places like Yellowstone wouldn't be the same without them. And things are about to get a lot worse, because a new study suggests that this slow boil is already happening. A recent paper published in the journal Geology warned that Yellowstone's geysers are in serious trouble. Researchers used seismic tomography to image the underground structure of Yellowstone's magma chamber. What they found was shocking. There are multiple diapirs bubbling up toward the surface, but at least one is moving faster than the others, and it's headed straight for Yellowstone's most famous geysers. If this magma diapir continues its current trajectory, it could boil the water table dry, killing Yellowstone's world-famous geysers. So when Steamboat Geyser finally erupted in August 2022, some experts worried that it wasn't just a sign that the geyser was reigniting after a long slumber. No, some feared that the eruption was a harbinger of things to come. Specifically, they feared that Steamboat had unleashed the worst-case scenario, a minor eruption at Yellowstone that would spell disaster for the region and possibly even the entire planet. You see, it's not the big Yellowstone eruptions that we should fear the most. It's the ones that seem minor that could be the worst-case scenario. That's because the magma reservoir beneath Yellowstone doesn't just extend beneath the park itself, it also extends beneath the nearby Yellowstone caldera. In other words, the magma chamber extends right beneath the site of Yellowstone's most destructive eruption 640 years ago. When the magma chamber beneath Yellowstone erupted 640 years ago, it sent over 240 cubic miles of material into the air. Over the next several weeks, this hot ash rained back down to Earth, covering much of North America in a layer of ash and causing widespread crop failure. But this wasn't your typical volcanic eruption. Even today, we're not sure what caused it. Some scientists think that magma from the reservoir beneath the caldera leaked into the magma chamber beneath the park itself. This caused a chain reaction that ultimately led to the catastrophic eruption of 640 years ago. Others think that it might have been caused by tectonic plate movement. Either way, this event remains one of the largest eruptions in history, and researchers worry that it could happen again, especially now that we know that a magma diapir is headed toward the caldera. See, when a magma diapir breaches the surface, it releases gases like carbon dioxide, hydrogen sulfide, and sulfur dioxide. Sulfur dioxide is notorious for its rotten egg smell, but it also wreaks havoc on the respiratory system. Exposure to high levels of sulfur dioxide can cause fluid to accumulate in the lungs, making breathing incredibly difficult. Studies show that exposure to just 5 parts per million of sulfur dioxide can cause respiratory problems in healthy adults. In children, the elderly, and those with respiratory issues, it only takes 2 parts per million to cause serious health effects. As you'll see, the real problem at Yellowstone isn't the eruptions themselves, it's the fallout. And that's why we need to talk about the biggest sulfur dioxide eruption in modern history. In 1986, a volcano named Laki in Iceland erupted. It sent over 200 billion cubic feet of sulfur dioxide gas into the atmosphere. This led to major disruption in the local climate. Some places near the volcano saw temperatures drop by 9 degrees Celsius. To make matters worse, winds swept the toxic gas across Europe, killing 700 cattle in Norway, 2,000 sheep in Sweden, and 80 people in Iceland. But that pales in comparison to what happened at Mount Pinatubo in the Philippines in 1991. Mount Pinatubo was a massive volcano that had been dormant for centuries. Then one day, it erupted. It sent 2.2 billion cubic feet of sulfur dioxide gas into the atmosphere. Winds quickly spread the gas around the globe, leading to a 5% drop in average global temperatures in 1992. But the damage went beyond the climate. Sulfur dioxide reacts with water to form sulfuric acid. This can then reflect sunlight back into space, leading to a slight drop in average global temperatures. This effect can last for years. But in 1992, researchers measured a different kind of damage. The amount of ozone in the stratosphere dropped by 10%. This was a major problem because ozone absorbs harmful ultraviolet radiation from the sun. Less ozone meant that more UV radiation reached the surface of the Earth, potentially leading to an increase in skin cancer rates. So if something similar were to happen at Yellowstone, we'd be in serious trouble. Not only does it sit atop a massive magma chamber that could erupt catastrophically, it also sits near a major transportation hub. If a minor eruption sent sulfur dioxide gas into the atmosphere, it could cause widespread damage both locally and globally. Unlike most volcanoes, Yellowstone isn't just a threat to those living nearby, it's a threat to all of humanity. For now, scientists are still monitoring the situation closely, but one thing's for certain, The next eruption at Yellowstone could be our worst nightmare.